like to invite Dr. Nordiana binti Muhammad Muztaza from University Related Science Malaysia. So Dr. Nordiana, so he got bachelor, also master and PhD from University Science of Malaysia. He's compared to me is quite young, but he's also very good. A lot of good publication, also good achievement, and in general, his research related with the geophysics. So it means for the student, also mostly for the University of Malang. There is quite a lot of women who are student in physics, so don't be also afraid to become a geophysicist. So says, okay, now it's time is yours. Okay, thank you.
Okay, thank you very much to Mr. Moderator. Assalamualaikum and good afternoon to everyone. Okay, so before I start, I would like to say thank you to the all committees, ICE-R3M, and especially to Dr. Siti Zulaika for inviting me to be as the invited speakers. So today, I will talk about the magnetic signal approach to the interpretations of meteorite impact crater at Bukit Bunuh, where Bukit Bunuh is located at northern part of Peninsula Malaysia, which is Perak. Okay, next. Okay. Alright, so these are the outlines of my presentation, which include introductions, objectives, study area, general, geology, methodology, results and discussion, and also conclusion. So actually, this study was planned by the archaeologists, in from Center for Global Archaeological Research in USM, Penang. So they found out that there could be something interesting at that particular area, where they found the investigation of suggested evidence of shock metamorphism, which is Soviet breccia scattered at that area, and also they also found crater at that northern part of Perak, which is at Lenggong, Bukit Bunuh. So as you can see, there are a lots of boulders like that scattered at the Bukit Bunuh area, and that boulders is not the same like any boulders, where it has a lot of bubbles. Okay, there's a lots of bubbles, and maybe it might be due to the high temperature and also high pressure at that area. So next, is it? Okay, alright, sorry. Okay, so based from the other researchers in the overseas state that there are two types of crater. Okay, it could be the first one, it could be the simple crater, which is the simple crater might be, the shape could be very smooth, bowl shape, and it fills with sediments, and especially the ejecta or breccia lens there. As compared to complex crater, the surface they could be the central peak here, where this is a bowl shape, and then there could be the central peak over here, and again there could be another bowl shape, and it has the slope of highly weathered area at the end of those crater, and call it as rim crater. And for simple crater, it has dimensions of about 2 to 4 kilometer diameter in size, while for complex structure it's about greater than 4 kilometer diameter. So at Bukit Bunuh, at first, they didn't know whether it could be simple or crater. So that's why they call us, so we are geophysics from physics department in USM. So they call us to prove the suggested evidence and also the diameter for the impact crater at Bukit Bunuh. Okay, so these are the models view. So it could be central uplift here, and it could be lots of fractures. And the red color is something that is very interesting, where it could be the Soviet breccia located at that area. So one of the possibility that area might be the meteorite impact due to the scattered Soviet breccia found at that particular area. Okay, so here the objective of this research is to detect the impact structure and structural attribute, to estimate crater dimension, and besides magnetic, we also integrate with other geophysical methods, because again, geophysics method is a tools, it's just the equipment, so we cannot rely on only one method, we have to integrate with other methods. But for my part, I only integrate with other geophysical methods, and of course, there are lots of geochemists, geologists that also conducted at that area. But my part is only for geophysics part. Okay, and here are the study area where, if you are not familiar with Malaysia, but I know everybody knows about Malaysia. So this is the location at the northern part of Peninsula Malaysia, and these are our location where it's the orientations is about north, south, and west, east. So we took about the study area took in stages, where we conducted during 2011 and finished up to 2014. So it's about 3 to 4 years to finish all these scattered areas. And the study was conducted around 11 kilometer north-south and 8 kilometer west-east. Oh, okay, I'm a bit slow. Alright, so these are again the photos taken, and a lots of boulders scattered. And actually the Lenggong area is near to the Perak River. So we cross from west to east, north to south of the Perak River area. Okay, these are, and you can see, this is what I'm talking about, a lot of scattered boulders found at that area. And there are also some geologists said, even though they found two same size of rock, but the other one could be rich in iron, so it could be heavy as compared to just normal rocks. Okay, so the general geology about that area, of course, it's alluvium, testradas, and also granitic rocks. And the granite intrusion occur throughout Malaysia at Mesozoic era, and pebbles dominated by quartz and quartzite are found at the elevation of about 200 to 350 feet in Lawing, Bukit Jawa, Kampung Telemong, and Kota Tampan, and also colluvium found at the lower zone. This is by the geologists, and a lot of fractures and fault found at that outcrops. Okay, here are maps where we draw again. We redraw the map, so you can see the Perak River is like undulating. Because the shape of the river also be interested by the archaeologists, where supposed to be, if you see from the whole map of Perak River, it could be straight, and then suddenly it's quite drastic change here, and then again straight again. So it might be something, or something would be occur somewhere here. So that's why we come and investigate what's supposed to be here. Alright, so for the methodology, the geophysical method for preliminary study, we conducted magnetic and also gravity methods. And then next, for detailed study, we conducted 2D resistivity and also seismic refraction. So there are 4 methods that we conducted there, and we finally we integrate to each other to prove that the size of the impact crater. And so those of this equipment, those of these geophysical tools, to find the impact crater dimension, and also to integrate all these 4 geophysical tools. Okay, so for magnetic, actually this one is our old equipment. So we just use, we just use geometric G856 proton precision magnetometer, and also attached with the GPS. But now we already had the new one, which is GEM equipments. And for magnetic, we conducted into 2 stages. The first one is just regional, meaning, and then the second one is detailed study. So for regional, we are moving from one point to another point, about 200 to 500 meters for each station. That is for regional, because we want to compare where should be the interested or suspected area. And then we came out the second stage. We conducted very detailed study, it's about 50 meters. So we have to cross all the bushes, all the swampy area, all the hilly area, we have to cross all over, okay, to get the good data. And how we do it, we put one fixed base at very good area, which is away from any magnetic noisy. So we take every data every 1 minute to get good data. Every 1 minute we put as a base, and for moving station, another one equipment, we just run all over 8 to 11 kilometers area. Okay, these are the studies. So, as you can see, the dotted black line here is our what we call it, our regional study, which is about 200 to 500 meters spacing. We just walk around all over here, and then for detailed study, we come again for detailed study. These are our survey. We are plan to do north-south and also west-east location. So these are the area of suspected to be. So that's why we plan 50 meters each station. Okay. Besides that, there are also archaeologists and from overseas come and get the distributions of the Soviet. So these are a part of interesting part, but I'm not expert in this to explain detail. But they found that a lot of the red color is Soviet Russia from scattered at that particular area. So as you can see, it's more towards west of the Perak River area. So based from the geophysics data just now, it shows that this particular area should be most interested area to be discovered. Okay, so these are the results for regional study. As you can see here, a lot of circular shape. Okay, about 5, most probably because we are not confirmed yet. Okay, unless we drill and we get sample. So there are about 5 very scattered area after we do processing, and the values is the range around negative 220 nanotesla to 120 nanotesla. So based on the interpretation, we might say that all negative values here, which is low values, might be indicated as possible crater. Okay, but we didn't know yet what are the size. And here, at the northern part, at the southern part, and the eastern part here, western part here, has high magnetic values. So it could be high magnetic values from the interpretation from the previous study state that it might be shallow bedrock located at this area, while for low magnetic could be deeper or very deeper bedrock. So it might be filled with something else. And here, after we conducted detailed study, we found that all the high magnetic values are located circular shape here. So it might be the possible to be meteorite impact is somewhere here. Okay, and those based from the interpretation and based from the other researchers' previous studies, we can say that those negative values might be the crater interior, which is filled with Soviet Russia, while the crater rim here, which has shallow bedrock, should be positive magnetic values. Other than that, to confirm the data, this is some of the previous researchers that we quote. They also got magnetics low values at crater interior. Okay, those by Desibin, Clarks, Henkel, Hart et al. And also Griff. So it could be magnetic lows at subdued zone, and rim and central uplift give positive result. So here, for example, you can see at the center here could be high magnetic values. So it might be for the preliminary results or discussion, we might say the dimension is about 4 to 5 kilometers, and it could be the complex structure because they have the patterns like here is the crater rim and here is the central uplift. Okay. Okay. Besides that, we want to prove again. We do details processing, which is signal analytic, to prove the data. So again, after proof, this is the original data we get, and after we do analytic signal, we still get the same pattern, which is the high magnetic results at the end, and also at the central uplift here, and lows at the center part of western and also eastern part of Bukit Bunuh area. So to prove, other than one method, we conducted gravity methods. Gravity also conducted at the same point like magnetic. So the first part is regional. We cross all over with 200 to 500 meters spacing. And then for detailed study, we conducted every 50 meters. Same point like magnetic. So these are the results because we know gravity is, the parameter should be density. So it also shows northern, western, and also southern part give high density values, high gravity values. So it might be again shallow bedrock as compared to the center part. It could be filled with sediments, filled with subabrasion. Okay, because it gives low density values. So the pattern also like this. So we might, okay, we're not confirmed yet. We might say that it could be the crater impact at this study area. Okay, after the preliminary study conducting gravity and also magnetic, and then we ran 2D resistivity and also seismic survey. So this our plan because based on geology information, we get a lot of scattered fault and fractured at this particular area. So we are confused whether to run survey like this, parallel or perpendicular. So what we plan is we do like fence orientations. So we will cover those areas. So based on this survey, we conducted about for west and south is about 0 kilometer from the west and 8 kilometer to the east, and for north and south is about 0 kilometer at south and 0 kilometer at the northern part, while northwest southeast is about 0 to 6.63 kilometer, and about 1.8 kilometer we run southwest to northeast directions. We cannot take this area because at that time the location was taken by the Warisan, Jabatan Warisan, so a lot of procedure to do, so we just stopped until here. But still we plan to do at the northern part here, because as you can see the river looks like drastic changes, but we didn't plan yet when to start our next research. Because for your information, at this study area we can graduate, we can produce 3 PhD students and 4 master students in geophysics part. So these I just simply go through. These are the results of 2D. We include the topography as well. So lots of fractures found based on the contrast, and it's validated with the geological map. And there are 2 boundaries different, which are around 100 to 800. It could be alluvium, very thick alluvium, 5 to 40 meters depth. And greater than 20,000 meter, it could be the granitic bedrock found at that study area. And as you can see, those are the constraints that we cannot go, like highway, roads, and also Perak River. And then again, we continue our survey from the west to east sides. And then this one, from north to south part. Okay, the same pattern, the same trend. Lots of fractures, a lot of faults, and it is integrated with the geology map. I don't have the geology map, sorry. Alright, and then this one is from northwest to southeast directions. Okay. And this one is from northwest to southeast. Okay, continue up to 6,000 kilometer. 6 kilometer. And the last one is southwest to east meter. So for seismic data, okay, actually we had 2 different software that we are using. This is the simple one. The oldest as compared to the other one is like tomography data. But I didn't include that even though we had, because resistivity already shows the coloring or the contour. So that's why I just choose this simple one to show the elevations of the data. Okay, as you can see here, there are steep slope located. So we can see clearly that it might be the cratering at that particular area, and it integrates well with the resistivity data. So based on the seismic refraction, it shows that there are 2 layers. Okay, the top layer might be the alluvium with seismic velocity of 400 to 1,000 meter per second, and which is alluvium mixed with boulders. And the other second layers might be the granitic rock, which have velocity values greater than 2,000. So these are also the same location like resistivity survey lines. So this is west east, this is south to north directions, and this one also at the end of the south to north, they could be very steep area, so we might interpret it as, because we compare with the magnetic and gravity, it could be the crater rim over here, and it could be the center of deposit area somewhere in the middle. Okay, same goes to this one, from northwest to southeast. So can you imagine that these are the hilly area that we came across and we conduct our survey. So we have to go and hike and take with the equipments as well. So here the data for the southwest directions, about 1 kilometer only. Okay, so both of two results we integrate and we get the models like this one is topography, this one is high, where it could be the shallow bedrock, and this one is the area that has lower topography, and this one we digitize the data from resistivity and seismic to get this one is very shallow bedrock and this one is a deeper bedrock. Okay, and then we create a model. So these are the model created from the software. And these are the one that I already stated just now. So based on resistivity and also seismic, it has two zones, two layers, and found lots of boulders based on resistivity and seismic values, mixed with alluvium as well. And also they could be a lot of fractures found at the survey line due to the effects of meteorite impact, most probably. And it was assumed that the subsurface bedrock of the site consists of granite and also clay soil cover. But lastly, bedrock strike in southerly direction and deep to the north-south. Okay, so last but not least, so all the conclusions have been achieved. Okay, as for now only, all the study can be successfully respond to the signatures of impact crater at Bukit Bunuh, and the magnetic response based on crater rim and rebound zone shows positive magnetic values, positive gravity values, while crater interior subgroup zones shows negative response towards magnetic and also gravity values. So based from the conclusion, we can say that the complex crater with rebound zone and has the diameter about 4 to 5 kilometer, or it might be greater than that. And the integration for 2D resistivity and seismic, we can map the fault and also fractures. And low magnetic and low gravity shows deeper bedrock, while high magnetic and high gravity shows shallow bedrocks. So I would like to thanks to Center for Global Ecological Research for give funding to us to do the research. Okay, thank you very much.
Okay, applause for the speaker. Okay, any question? Okay,
very interesting, thank you. I guess my first question is, you mentioned briefly that you had shocked quartz in the swayvite rock that you had. That's you had deformation features in quartz, or you had quartz polymorphs?
Thank you for that question. You are asking about the Soviet quartz and quartzites, is it?
So yeah, within the swayvite, did you find quartz polymorphs such as stishovite or coesite, or did you find deformed quartz?
Oh, actually, it's just scattered all over that area, the Soviet. Yes.
Yeah,
yes.
And within that swayvite, the shocked quartz that you mentioned, is it deformation features or polymorphs? I guess.
I'm not sure because that one is not my part. It's actually from the geochemist part. We just received the data just to prove with the geophysical interpretations.
Okay, so then you might not answer the second question. Is if there's a glassy component in the swayvite.
The classic.
Glass. If there's a glass.
Glass. Okay.
Glass. Because if so, you could date it, and then I guess that leads into my next question. Do you have a sense of how old this structure is?
Oh yeah, sorry, I forgot to tell. It's dated about 1.83 million years ago.
Using what method?
We give the samples. I'm not sure because that part is from archaeology's part. They send the data to Finland, if I'm not mistaken, and also Korea to prove the date. They have the equipment, but not in our university. We don't have the equipment.
Okay, very interesting. Thanks.
Okay.
Oh, actually, one follow. Do you have a sense of the erosion rates here? Because you're saying that this crater is still in the surface morphology. Basically, it's expressed in the.
Yes. We can see clearly from our naked eyes, and we can also see the very big boulders surrounded the area.
Okay, and it's about 1 million almost 1.5 million years old. So
Yes,
and
yes.
that's consistent with regional erosion rates.
Yes.
Okay, thank you.
Thank you.
Maybe once more. Oh. Another one? Okay, maybe another one.
Okay, thank you. What is the inclination in your location?
What do you mean by inclinations?
Inclination magnetic.
We didn't measure for that. We
Okay.
just measure the magnetic values around the study area. We didn't mention details about that study.
You can see in maybe IGRF the inclination in your location maybe. Why you not use reduced to pole?
Oh, okay.
You direct to interpretation residual.
Residuals.
Yes. Why you not reduce to pole? After that you forward modeling your magnetic.
Okay.
You use four method. Sometimes we need just one method to.
Yes.
Or-
Alright, thank you for that questions. Actually, what you are asking is correct. It's just that we don't have that tools. So we just have the very simple tools. That's why to more details, of course, you can see only one method can prove, but we have to do lots of analysis to prove. But that's why we are not concentrating on that particular area only. We combine with the other geophysical method to prove due to the lack of equipments that we had in our lab.
Okay, thank you. Applause again for the speaker. Okay, the session for this is finished. So before I finish this session, I would like to say once remarks. First, maybe from the Professor Satria. So it means that so don't afraid to dream. Yeah? So if you do hard work, conscience, and also, of course, pride to do that, so the dream will become true. Maybe that's because. And then the second one is also for the Dr. Nordiana. So in general, that's geophysics is dominated by men in general. So and what Dr. Nordiana proved that even a beautiful woman like her also can be a very good geophysicist. So that was okay. Thank you very much.